Okay, today we're looking at the areas of regular polygons being polygons with congruent sides. A couple terms that we need to talk about before moving on to what is just the formula for that. The first thing we need to look at is central angle. A central angle of a circle is an angle with the vertex in the center of the circle. Now, that's when we're dealing with circles. Its sides contain two radii. Now when we're talking about a polygon, for instance, we have this pentagon. I know it's not drawn regular, but imagine it's a regular polygon. It's drawn from the center. The radii goes to the vertex. So the central angle is formed by those two radii. The radii again from the center to the vertex. So this has, unlike a circle which has an infinite number of radii, this pentagon has has 5 radii. The apothem, the second part of this, like the radius of a circle, the apothem is a segment from the center of a regular polygon, and it is perpendicular to a side. So if we were to have a, let's say we have an equilateral triangle, which is a regular polygon, the apothem is from the center and it goes perpendicular to the side. So it has 3 apothems. So like the radius, the number of apothems is equal to the number of sides, like the radii. So with that information, let's take a look at the first problem, practice problem in our notes. Well, this says, we have the formula up here. It says the area is equal to 1/2. So here for this example we're going to do, we have 1/2 times the apothem, which looking at the picture is this side right here, but we don't know what it is. So we'll just kind of skip that for now. Apothem times n, which equals the number of triangles or the number of sides. This is a hexagon, so it has 6 sides. Times s, which is the side length. In this case, that side length is given to us right there. It's 3. So we need to figure out what the apothem of this hexagon is. Now notice, let me magnify that triangle we have. So we have this triangle. The whole length is 3. So half of that length is going to be 1.5. Now if I could find out what these angles are here, that I possibly could figure out what our apothem is, that x right there. Well, remember the central angle that we just talked about in the notes. This figure has how many central angles? It has 1, 2, 3, 4, 5, 6. So one full rotation would be 360 degrees. Well, there are 6 angles in there, which leaves us with a central angle of 60 degrees. So this whole entire angle is 60 degrees. Well, half of that, this angle, is 30 degrees, which makes this 60 degrees. So we end up having a 30, 60, 90 triangle. If you'll recall, our short leg right here is 1.5. We're trying to find out what this long leg is. And if you'll recall, short leg to long leg, you multiply by radical 3. So what's the length of x? 1.5 times radical 3, and that's 1.5 radical 3. We plug that into a calculator. 1/2 times 1.5 times radical 3 times 6 times 3, and you should get, rounded to the nearest tenth, 23 4/10 square meters. Okay, that's just by plugging it in. Now, the other thing, and that'll be the hardest type of problem you'll come across in this assignment today. But another example that we could come across, and our notes are incorrect, it should be radius squared right there. But if we have the radius, remember, from the center to the vertex, we use this formula. The previous formula was when we had the apothem, or we're using the apothem. But if we're given the radius, we can just use this formula, which all we have to do is plug it in. 1/2 times the number of triangles, which in this case is, number of sides is 5, it's a pentagon, times the radius squared, well, the radius is 5, so we square that, times the sine of the central angle. Again, central angle is formed by the two radii. Well, it's going to have 5 central angles. Number of central angles is equal to the number of sides, so we take 360 degrees, divide it by 5, and we end up with 72. So in our calculator, we punch in 1/2 times 5 squared times the sine of 72, and it should give us an area of 59/4 square centimeters. Okay, this page of notes, this was your formula sheet. This comes in handy for all the stuff we've been looking at, so if you didn't know that that was in there, there it is. And this is the area of a triangle, or not, when we don't have the height of it, but we have 2 side lengths, and then we have the center angle. So let's look at that in our assignment. Now the other note down here, this is what we've already done. When we have the radius, kind of the shortcut, which is the same thing that we did in the previous one. So let's look at your assignment. The triangle problems. Refer to that triangle formula we just kind of quickly passed over. But remember, it is 1/2 times the side length, which is 7, times the other side length, which is 4, times the sine of 146. Plug that into your calculator, and you should get 7 8/10 square kilometers. Okay, again, you're just plugging it in to the formula. 1/2 times the sides, 8 times 6, times the sine of our angle, 138. Okay, looking back at numbers 1 through 4, here, this is easier than the example we did, because in these problems, they've given you the both the apothem and the side length. You recall that the formula is 1/2 times the apothem, 7.3, times the number of sides, which is 5, times the side length, 10.6. And when we multiply that product, 1/2 times 7.3 times 5 times 10.3, you should get 193.5 units squared, since we don't have units. Okay, so that first section, 1 through 4, you should be fine on. 5 through 8. 9 through, this is one of those where we have the radius. So we're going to use that other formula, where we take 1/2 times the number of sides, times the radius squared, times the sine of the central angle. Well, remember, the central angle you find by getting 360 dividing by the number of sides, equaling 120. So the sine of 120. Plug that in your calculator, you should get 332.6 units squared. Now the tricky part is going to be this section right here down below. You're going to do the same thing. This one, they give you a side length, but they don't give you the apothem. So you're going to create a triangle, find out what the central angle is. This polygon has 7 sides, so 360 divided by 7, which is going to equal, what is that, 51.4. And to find this angle right here, we're going to take half of that, which is 25.7.
What are you doing?
expanding that triangle. Half of 2, the whole thing is 2, so this segment is 1. We're looking for x. We're going to use the tangent ratio. This angle is 25.7. So the tangent ratio of 25.7 equals 1 over x. Solve for x. That is your apothem. Plug it into your formula and you should be good to go. The other three are kind of tricky. You have to look at it like that. Hope that helps.